Hello again, everybody, and welcome to the third in this series of short videos that I'm doing to introduce a radical but logical alternative to the standard model of both quantum mechanics and cosmology. In the previous two videos, the first one was an introduction, and the second one was basically dealing with the atom, or my alternative version of the atom. In this video, I would like to tackle the subject of light, or to be more precise, electromagnetic radiation, because I think there's some misconceptions in this, in the way it travels and that kind of thing. And it's quite important to understand electromagnetic radiation in relation to the standard model's claim of an expanding universe and the evidence that's been put up for it, which is there's only two pieces of evidence cited, and that is the cosmic microwave background and redshift. And light has a particular effect with redshift. So rather than waffle on, light, what is it? Basically, the standard model has it as a wave, and it's obviously often referred to as the different wavelengths of light, from ultraviolet, infrared, gamma rays, X-rays, all this kind of thing. Anyway, what is a misconception is that light travels as a wave. It doesn't. Einstein said that he realised that light consists of pulses of energy, packets of energy, that he termed quanta. And I agree with him. So if we follow that scenario, when light is emitted, and when I talk about light, I'm talking about all electromagnetic radiation. All it is photons being emitted from an atom. Photons are the ones in the optical range, what we refer to as light. But basically, it's pulses of energy being released from the atom, and they're released in pulses. Light has frequency, and the frequency is the number of these pulses being released over a period of time, and we measure it in so many pulses a second, and all the technical stuff refers to the wavelength and the frequency being how many waves, complete cycles of the wave pass a given point in a given time. So anyway, if it's just pulses that are released, then there's obviously a gap between them. Now, the higher frequencies of electromagnetic radiation, we'll say the ultraviolet, obviously there's higher than that, and then when we come down to the redshift, there's lower ones than that as well. But basically, what we can think of is that the pulses, the distance between the pulses of your ultraviolet, your blue light, are quite close together in comparison to red, infrared, which are further apart. So if we consider that the standard speed of light is said to be 186,000 miles a second, which is rattling on a bit, if we take the two examples, which is the ultraviolet and the infrared, passing at that speed, passing a given point, there will be vastly more of the ultraviolet pulses pass, a given point in 1 second, than what there will be the red side of the spectrum. So if we keep that in mind, then when we come to arguing about the Standard Model's description that the universe is expanding, and that is because of redshift, and redshift is because of an expanding universe, and that's stretching what they say is the wavelength of light, I propose a different answer than that. I've drawn a little diagram here. We might be able to get some inspiration from it. So I don't know how well you can see this, but if we say, for argument's sake, that the blue end of the spectrum, the pulses are quite close together. So if this is travelling at the speed of light, past a given point, there will be a certain number of pulses go past that. If we're in the red end of the spectrum, then at the same speed, the distance between those two is greater than obviously these are. And passing that point, there will be less goes past than that. Now, when astronomers and cosmologists look back and decipher the light that's coming from billions of years ago, they say because they're seeing it in red, they know that when it was emitted in the blue end of the spectrum. And they said because it's travelled all that distance, because the universe is expanding, the distance between these pulses has got wider and brought it down so that when it's being observed at this end, it looks in the red end of the spectrum. Well, I disagree with that. I say the universe is not expanding and the light hasn't been stretched. I say that what's happened to the light over the time and distance is that the speed of it has reduced. These two lines are running at the standard speed of light, which is 186,000 miles a second. But if we look at the light that's observed coming back from billions of years ago, if it started out at the blue end and the distance between those pulses was a certain amount, by the time it gets to us, the distance between those pulses is exactly the same as when it was emitted, but it's taking longer to pass this point. So it looks as though the distance between them is greater. I think most people would agree that that's a reasonable scenario if this is travelling much slower than what either these are. And I claim and propose that not only does light slow down and lose energy over distance and time, I also claim that light has got a finite distance that it can travel. And that's where it comes in with the cosmic microwave background. If, say, for argument's sake, light travels billions of years, and you consider the distance that's travelled in that time, it's certainly not unreasonable to consider that it's actually dropped in speed. And there's a number of people that have proposed this, and and believe this to be the case, and it's referred to as the tired light theory. And I believe it stands up. So, bearing that in mind, if light does lose speed, and that will account for the redshift that we see, that means that the universe is not expanding. And that is what Einstein believed all his life. He reluctantly sort of conceded that it is expanding because of the discoveries by Edwin Hubble, who discovered this redshift and thought to himself, right, that shows that the light is being stretched, but he was mistaken. It was pretty well compounded by when the cosmic microwave background radiation was discovered. Because two chaps, Penzias and I don't know, I can't think of his name, it's gone out of my head. Penzias, Arno Penzias and somebody else. Anyway, they was working on a radio transmitter, and they was hearing this faint background hum all the time. Wilson, I think, was that Penzias and Wilson, and they couldn't figure out where it was coming from. And in the end, they decided that this was radiation coming from, because they could pick it up in every direction, everywhere. They thought, oh, this bolsters the Big Bang theory, and we reckon this is the afterglow, the radiation from the Big Bang. Well, quite honestly, that's, like I said before, this is sort of fairy tale physics, because it's completely impossible. So, as I've said, we need to find a different explanation for the universe not expanding, and for alternative explanation for redshift and for the cosmic microwave background. Now, I believe that not only, like I said, not only does light slow down, but it has a finite distance that it can travel. And because when the cosmic microwave background is observed the same distance as what they say the age of the universe is, it's pretty obvious that there's something going on there, and the fact you can see it in every direction. And I maintain that what you're actually seeing is a point where light reaches saturation point. When you think of all the rays of light coming at us when we're looking, doesn't matter what direction we're looking in, but you think of light that's been travelling billions of years from all the galaxies and stars and whatever, and it's not just, we're not talking just about visible light, we're talking about all the frequencies of electromagnetic radiation. There's an enormous amount of stuff bombarding us, and I would say that the cosmic microwave background is a point where we can see back to that particular point, and then there's so much light that is coming from every direction, it reaches a saturation point. And because I believe that the universe is infinite, and it's always existed, and I believe it will always exist. And if it goes on beyond the 14 billion years that we can see, or 13.8, they say it's 14 billion years, if it extends beyond that, which I'm absolutely certain it does, and it goes way, way, way back, I don't believe it's got a beginning. I believe it has always existed. There's no age to it. It's absolutely ageless. You think of light that's travelling from all those galaxies further back. Like I say, there gets to a point where that light has run out. It's finished. That's a point where there's so much light coming from every direction, you get a saturation point. But also, if you think about it, the fact that when we look back in any direction, there's a limit to how far we can see. And at this point, with the wonderful James Webb Space Telescope that we've got, it amounts to around about 14 billion years. And the fact that that's the same in every direction you can see, it must make you question the validity of the standard model's description of it. The problem with the Big Bang theory that they put forward with cosmic inflation, there's so many problems that crop up with that. Like I say, first of all, it's totally and physically impossible to happen. But also there's the horizon problem, where there wouldn't have been enough time for all the matter in the universe to have come to a standard temperature. But with a static universe that's always existed, you haven't got this huge so-called Big Bang. So therefore the universe is at that temperature all the time, and the only difference in temperatures, because there's a variation in the cosmic microwave background where you've got slight fluctuations in the average temperature. This can easily be explained by the galaxy density that obviously, although it's pretty much the same all over, you will have areas that have got more galaxies in than other areas. And also you've got supernovas and hypernovas and God knows what else going on. So because it's a dynamic medium that's it's sort of active, it's alive, things are happening in it all the time. You're getting stars explode and stars dying, matter being thrown about in every direction and then clumping together again. It's not unreasonable to have a situation where the radiation coming from every direction will be fairly uniform, but it will have slight variations in it. And I think that pretty well debunks the Big Bang right from the word go. And the James Webb Telescope is proving that over and over again that the Big Bang theory is wrong, because there's galaxies out there that are, fully formed, and according to the cosmologists, there's not been enough time for that to happen. So it's simple. Accept the fact that the Big Bang never happened. Accept the fact that the universe is not expanding, because the explanation for redshift is misguided. There's another explanation for it. And the cosmic microwave background is not any leftover heat and radiation from the Big Bang. It's merely a function of the fact that we can only see back that far, and light gets to, or the radiation gets to a point where you've got saturation point, you can't see beyond it. There's an awful lot that could be looked into with this, but I'm pretty certain that that is how it works. And I've explained it probably a bit better than what I have done here in, the book, which is the title of the hypothesis that I've put forward, you know, the two monopole particle universe. And if you want to read, I'm intending to try and do some more of these videos covering various parts of it. But if you want to read it straight off, it's available from Kindle Bookstore. It's available on Kindle. It's easy reading. There's no mathematics in it. The only little bit of figures that I do put in there will be to do with redshift, basically, because when you consider that light that's coming to us and has travelled around about 14 billion years, if you just took that as being the age of the universe, which it's not, it's a lot more than that, light starting off at 186,000 miles per second, it would only have to lose 1 mile per second every 140,000 years to go right from the blue end of the spectrum down to the red. So that's a really good point to consider. I mean, it's certainly not unreasonable. So anyway, I hope to get back to you again with a bit more. So anyway, one thing I would ask, what YouTubers do, and I'm not a YouTuber, if possible, could you please click the like button and subscribe? It doesn't cost anything, it's completely free. And also, if possible, can you watch it to the end, because that helps as well, and pass it on to any of your mates or whatever. Anyway, thanks for clicking on. Look after yourselves. Ta-da then. Bye.